All right, this video is going to take us through 24 questions, practice questions for Algebra Air test from Arizona. So I'm going to call this the USS John McCain. Oh, wait a second. How about the Air John McCain? He's the most famous person I could think of off the top of my head that's from Arizona. All right. When we're working through these air questions for Algebra 1, the thing that we want to understand here is some relationships between equations. So if I have y equals 2x versus y equals x squared versus y equals 2 to the x, we have to kind of understand the difference between these equations. And of course you could write this in function notation. You could say f of x equals this instead of y equals. So you could say f of x equals 2 to the x, f of x equals x squared, etc. When we have 2x, the exponent is 1. So we call this a linear equation. I mean, the graph makes a line. When we have x squared, we call this a quadratic equation. And when we have the exponent is missing, see, the exponent is missing, so we call this a exponential equation. So we have linear, quadratic, and exponential, and they kind of want you to understand the difference between these two, or between these three, I should say. So linear makes lines. So 2x makes a line that goes up like so. X squared makes a parabola like so. And 2 to the x is exponential. It grows really fast. Okay, it grows up really super fast. So we can look at this in table form. If you put 1 into this equation, you would get 2. If you put 1 into this equation, you get 1. And if you put 1 into this equation, you get 2. But if you start putting bigger numbers in there, then the numbers change really fast. So let me compare these three things. I'll use the calculator to show this. In fact, let me go ahead and just graph them all in here. I'm going to pause it for a second while I type these in. All right, I went ahead and typed all these in here. So I have 2x, x squared, and 2 to the x power. So I have linear, quadratic, and exponential. So if I look at the graph of them, you can kind of see the graph I made. We got the linear is the line, the x squared is the parabola, and then 2 to the x power is, you kind of see it as this black line that's right there. Well, exponential rises really super fast, quadratic rises pretty fast, and then line just keeps going up at the same rate. You can see that here in the table. If I go to second table and I have it to ask, if I put 0 in here, then the line is 0, the quadratic is 0, and then the exponential is 1 because 2 to the 0 power is 1. But then as I start putting in numbers like 1, 2, 3, hey, they're all the same at 2, 4. And then exponential here is kind of rising kind of slowly in the beginning, but it really takes off here in a second. 4, 5, 6. So 6 gives me 12 because 2 times 6 is 12. And then 6 squared, so I square, that gives me 36, so that's 6 times 6. So I got 2 times 6, 6 times 6, and then 2 to the 6th power, which is 2 times 2 times 2. So the exponential is rising super, super fast. 7, I see I'm only 14, and that's 49 because that's 7 times 7, and then that would be 7 times 7 times. It just keeps doubling every time. And then 8, and then 9. So exponential kicks linear's butt, exponential kicks quadratic's butt, quadratic kicks linear's butt as x gets larger. Now if you go the other direction, let me clear all these out, kind of the other thing happens. So delete, 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 delete. Now let's go the other direction. Remembering that this is linear, quadratic, and exponential. So if I do 0, that's where we started with, -1. So now this is going to get really small really fast. This is going to get really big, and this is going to get big negative. So there's 4. Whoops, I skipped some, didn't I? 6, 8, 10. So this would be 2 times negative 10, which is negative 20. And then negative 10 times negative 10 is 100. So it gives me the 100. And then this would be 2 to the negative 10 power, which is a really super small number. You can kind of see it over here. It's in scientific notation, but it'd be like 0.00097, etc. This one here is that. All right, let's start buzzing through the problems. Okay, here's the first one, and it gets what I'm talking about here. It's asking, it says we have these, which is true for large numbers, right? So x is positive large numbers. Well, there's your exponential and there's your linear. Well, exponential eventually will start kicking linear's butt if x becomes larger and larger and larger. So we're saying that the q function, this is function notation, the q function is bigger than the r function, so the answer is C for large values of x. So this one's going to grow really fast. This one will just keep going up. So exponential is going to be like woo, and linear is going to be like nyeh. Okay, it's just going to grow constantly, where this one's going to grow really fast. The next one, number 2. So we're going to set up a system of equations here. The bucket is x and the drink is y. So we have some friends spend a total of $12 on popcorn and drinks at the movie theater. And x is the cost of a bucket. No. The bucket will cost $2 and the drink will cost $1.50. So we're going to create an equation to represent the relationship between the number of buckets of popcorn and we bought for $12 here. Oh, and so the relationship here is it's $2 for each x. So that's what you would type in here. And then it's $1.50 for each y, and that's $12. So that's what it says here. It says create an equation, and they spent $12. So it's $2 for each x, $1.50 for each y, and that equals a total of $12. And then it says they bought 4 drinks. The drinks is y, so y is 4. So we do 2x plus 1.5 times 4 is equal to 12. So then this answer goes in box B. So we have 2x plus, multiply this together, and you can use a calculator. You don't have to know all the ins and outs of multiplying this, but you can think $1.50 plus $1.50 plus $1.50 plus $1.50. It's not too hard to figure out that it's $6. And then 12, and then we do basic algebra. 2x is equal to, subtracted over 6, divide, x equals 3. So 3 would go in this box there, and that's how many things of popcorn they got. You could almost guess and check this in 3, and 3 goes here, 4 goes there to make $12. So that's not too bad. All right, number 3. Okay, so this one here is a fairly challenging problem. And so you don't have to get every question right to be successful on this, but you do need to get the easy ones correct. And I wouldn't call this an easy question. So this is the vertex, the h and the k, and this is some x and y. And we're going to write the equation of the parabola based on the h and k and x and y. So your base formula is y is equal to ax minus h squared plus k. So that's the quadratic. The minimum is the vertex, the h and the k, and it passes through some xy point. All right, that's the g function. Wait a second. Oh, that's the f function, and then the g function is the other one. My bad. So this is the g function, and the f function comes from these 2 points here. So f of x is equal to ax minus h squared plus k. So we're going to put in the h and k. So we have h is -2, so it's a double negative there. So that's going to be, and the x value is 2, so it's going to be 2 minus a -2 squared. So the x is 2 and the h is -2. K is -3, and then a, and then the output of the function is 13. So that's my y value. So there's my x and y and my h and k. And I have to solve for a. And that would be 4 squared is 16. So it's 16 times a. So we're going to add over the 3. So 16 is equal to 16a. So we added the 3 over, and then we have a is 1. So now we know that the equation for f is equal to 1, and then it's x minus h, so it's going to be plus 2 squared, and then minus 3. All right. Now we have to compare that to the other function, see how much greater the one y-intercept is compared to the other. So I need to put this in standard form. So f of x is equal to, I need to multiply x plus 2 times x plus 2, and then minus 3. So f of x is equal to x squared. Then this would be 2x, and that would be 2x. So it would be 4x plus 4 minus 3. So f of x is equal to x squared plus 4x plus 1. So that's the f equation. So we have to compare that to the g equation. Well, the g equation is negative x plus 2, x minus 3. So g of x is equal to, now I have to FOIL this out to compare them. So this times this is x squared times the negative 1 would be negative x squared. This times this is negative 3. That times that is positive 2. So negative 3x, positive 2x makes negative 1x. Times the negative makes it plus 1, or just plus x. This times this is negative 6 times the negative in front makes it plus 6. So you have to compare the y-intercept to each of these. Well, this y-intercept is 1, and this y-intercept is 6. So it says how much greater is this one compared to this one? Well, it's 5 spots greater. So it's 5 units greater. All right. All right, this is a matching problem, and what you do with this is on the computer, you take and slide these in here. And we're going to call this 1, we're going to call this 2, and then 3 and 4 and 5. And what it is you grab the mouse and you slide the appropriate answer in here. So you're solving this equation over here, and it's drag and drop. So there's the given, and you're supposed to look here and see what happened. Well, it looks like they multiplied 4 through the parentheses, so that's called the distributive property. So that'd be number 4, so you'd slide that in there. Then they rearranged the order here. So you can rearrange the order of addition anytime you want to. It's called the commutative property, so that's 2. And then they put together the like terms. They associated them together. So that's the associative property of addition. So that's number 3. All right, next page. And number 3 was kind of a killer, so don't be depressed. This would be n of t is equal to 2 to the t power. And it's, so the Petri dish, it's a number, and it's random for number, t is time, and they are doubling because it's 2. It's an exponential, so they're going to double really fast. So if we do 2 to the 8th, would be 2 to the 8th here. So the way in function notation works, if you put t is 8 into the n function for number of bacteria, then it appears over here. So it's 2 to the 8th, which is 2 times 2 times 2 times 2 a bunch of times, which is 256. So it's 2 to the 8th. You can put that in the calculator and see what it is. So we know that the answer is A or B. So 2 to the 8th means there's 256 bacteria after, not 256 hours, after 8 hours. So the only one that makes sense is that one. Okay, now we're going to rearrange an equation. We have P is equal to M times G times H. And we have to solve for H. So we're going to divide over the things that we don't need. So we're going to divide over the M and divide over the G to get H by itself. So that cancels out, that cancels out. So H is equal to P divided by mg, and that is choice C. All right, I'm going to pause it here for a second. And back. All right, so now we have to put together our like terms. So I'm going to write this down, distributing the negative here, pretending like there's a -1 here. I'm going to distribute that negative through the parentheses. So I have to think I'm going to subtract all these parts. So it's 2r squared plus r minus 1. A negative with the 3 would be minus 3r squared. A negative with the positive is minus 4r, and a negative makes positive 5. Now we put together the like terms. So these go together. You put the r squared with the r squared, you put the r with the r, and you put the number with the number. By underlining, I can see what like terms go together. So it's 2 minus 3 is negative 1, so we know it's a or b. We have these two would be negative 3 because it's negative 4 plus 1. So the answer is A. Okay, now we have a system of equations, and we're going to solve the system of equations by, we flip to the right page here. Oh, here we are. Okay, we're going to solve this by, I'm going to do elimination method. You could graph these and see where they cross, but sometimes it's just easier to do the algebra. So we have 4c plus 2d is equal to 11. And I'm going to bring the c over, so I'm going to do 22c plus 7 halves d is equal to 41. All right, so what I'm going to do is I'm going to double this equation, which will kill the 2. All right, so I'm going to double this equation. So it's going to be 44c. So I'm going to put parentheses here. So I'm going to double this equation, and that doesn't change where the lines will intersect. It just makes, because it's the whole premise of what you do to one side of the equation, you can do the other. So 44, 7d, and 82. I like to keep things alphabetical when I do systems of equations. It just helps me stay organized. So I'm going to do C and then D. And now what I want this up here to be negative 44. So I'm going to multiply this equation by negative 11. So this times this will be negative 44c. This times this will be negative 22d. And that times that is negative 121. Then you can add the two equations together, which eliminates the variable. So this gets eliminated, and then I get negative 15, because you put those together, you get negative 15d, and negative 39 when you put these two together. Don't freak out. When I divide over the 15, I will get a decimal. It's positive 2 6/10. So that's d, so you got to type that into the little box. And then you have to back substitute. You got to put the 2.6 back in, and you can do that probably right here. And with the calculator, let's do it with the calculator to save ourselves some effort here. So I'm going to go off of the home screen here. 2.6 goes back in for D, so I have 7 divided by 2 times 2.6. Okay, and that's 9.1. I'm going to subtract over the 41. Subtract 41, okay, and then I have to divide the negative 22 over, so I'm going to divide by negative 22, and that gives me 1.45. And there's my answer. Okay, number 9. Okay, this is a factoring problem. You're going to write it as the product of two binomials. So this is the difference of two perfect squares. So we do x squared minus 12 and x squared plus 12. So it is the difference of two perfect squares. 144 is 12 times 12, and there's my two binomials. You type it in there and all that good stuff. Okay, number 10. We have a linear function here. And it says create a linear function g of x so that f of x equals g of x has one solution. And what is the exact solution? So what I did is I made them intersect at the same point. Okay, so this intersects at 0. Well, if you put 0 in, you get negative 3 back. So I was like, well, let's just make it the simplest function ever. So x minus 3. So this is the point of intersection, negative 3, negative 1, negative 2, negative 3. Well, this one comes through with a negative slope, and this one comes up with a positive slope. So they're going to intersect at that point. And so where is that point of intersection? Well, I made it be 0. So I created, basically you have to have not parallel lines, but you need to have a different slope and have it intersect. And I was like, well, that's the simplest place for it to intersect is on the y-axis. Okay, number 11. Okay, this is an upside down parabola, and I know that it says for which values of t is it positive and increasing, so it has to be positive and increasing. So if you can remember parabolas, if you put 2 into this function, it's going to be 0, and if you put 8 into this function, it's going to be 0. And this is an upside down parabola, and 5 is the middle point, because that's where the vertex is. Now how do you find the vertex? You do x is equal to negative b over 2a, so it's going to be negative 10 over 2 times negative 1, because your a is negative 1. So the vertex is at 5. So 5 is the vertex point. It's an upside down parabola. If you factor it or graph it on the calculator, you'll see that it crosses the intercept at 2 and 8. So it's positive on this interval between 2 and 8, but 2 and 8 is not part of the problem. It has to be positive and increasing, so it's increasing and positive in this little baby interval. So that is C. Okay, number 12. Well, another thing I guess I did with 11 is I set it equal to 0, like to factor it, because it factors so easy to find those two spots. And I don't like factoring with the negative there, so I multiplied everything by negative 1 plus 16 is equal to 0. So then it factors into t, forget that part, t minus 2 and t minus 8. So you can see that 2 and 8 are the two solutions. Okay, or you can graph it and see the two solutions. All right, the next one, number 12, a function. Oh, this one here is a bit of a beast too. So do what you can with it. Let's see. 16. Well, let's see. Let me think about this for a second. Okay, so the function has a minimum value of 80. Okay. So that means that I know k of the h and k, the vertex. So k is equal to 80. So if I do, and I know that my coordinate point here is negative b over 2a, and a is 1. So negative b over 2a, which would be 2, comma 80. That's my h and k, because the h is negative b over 2a, so it's 1. We did that in an earlier problem. So h is equal to negative b over 2a. A is 1, so that is my vertex. Okay. Then it's been a couple of days since I've done this problem, so it's like, wait a second. So I know that if I put a number in, aha, it just struck me. If I put a number in for this, if I put in negative b over 2a over 2 in for x, then out is going to come 80. So if I put in the h, this is my h. If I put h in, k comes back. So then I can algebraically now solve for b. That's how you do it. So it's after school and my brain slowed down there for a minute. So the vertex is negative b over 2a, and the vertex is negative b over 2 because a is 1, and then 80 is the k because that's the minimum value of the function of this parabola. So now I'm putting the numbers into here. I put in negative b over 2 in for x, and I get back 80 because this goes in, 80 comes back. So 80 is equal to, square this, and it's going to be b over 4. And then I multiply this together, negative b squared over 4 over 2 plus 144. All right. I'm going to subtract over the 144 to get negative 64. And this is 1/4, and then minus 1/2 would be negative 1/4 b squared. And then I'm going to multiply over the 4 to get rid of the fraction. So I get 256 is equal to b squared. So b has to be 16. So 16 is the answer for this one. Oops, I went off the screen. I lost my concentration off the screen. So this is not necessarily my best effort of going through a problem. So I put in negative b over 2 in for the x, and I get back 80. And then I squared this, and I multiplied this. So and then I subtracted over this to get here. And then I have 1/4 minus 1/2 is negative 1/4, b squared. I divided over 1/4 or multiplied over the negative 4, however you want to think about it, and then took the square root, and I got 16. All right, number 13. Hopefully an easier problem next. Okay, 13. It says, let g and h be integers that satisfy the given conditions. So if you multiply the two things together, it's rational, but if you add the two things together, it's irrational. Well, I picked 2 and 8 for this because if I do 2 and 8, that would be the square root of 16, which is 4, but if you do the square root of 2 and the square root of 8, it's different. And you could put these numbers into the calculator and check it out. Okay, number 14. It wants to know the rate of change over the interval. So we have a falling ball. We need to put these numbers in for t and then figure out how much it's changing. So I have t and I have f of t, and okay, t and f of t. So I need to put in 0.75 and 1.25. I put these two in for t, and then I get back the height of the ball. So when I put this one into the equation, I got a height of 10, so I typed it into the calculator. When I put this one in, I got a height of 4. So then I need to know what's the change. Well, it's going to be this minus this, so it changed that many feet, and then this minus this, which would be 1.21 minus 25, sorry, minus 0.75. So it'd be negative 6 over negative positive 1/2. And then you get negative 12. So it's going down at a rate of negative 12, and it's feet per second. So it's down negative 12 feet per second. Because you do this divided by that, it's going to be negative 12. All right, number 15. This one here, you have to recognize the exponential part of this. So population is changing 2.5%. So that's changing 25%. That's the one that's changing 2%. And this is an exponential equation. So there's my starting population is changing 2.5% for so many years. So the answer is C. Number 16. All right. This one here, you have to read through and be very careful with the numbers and stuff like that. Make sure everything adds up and all that good stuff. basically you need, let's see, how did I do this? It's been a couple of days again since I've gone through this, so I think I'm going to pause it for a second and to remember real quick. All right, my brain is refreshed. So I have surveyed this many people. 24% do not have a sister. So you're going to do 24% of 525. So 0.24 times 525 is 126. So we know do not have a sister. That's the total. 126 goes there. And it says 68% of the people surveyed have a brother. So we need to do 525 times by 0.68 is equal to 357. So all these people have a brother. So there's 357 there. Okay, now it says the results also showed that 93 people surveyed do not have a sister and do not have a brother. So no sister, no brother is right here, 93. So now we can just start like going across here. Well, this number plus this number has to equal this number. So that means 33 are missing here. And then this number plus this number has to be this number. So that's going to be 324. And then let's see, this number plus this number has to be this number, so it's 168. And then this number plus this number has to be this number, so that means this is 75. And this number plus this number has to be this number, so it's 399. And this number plus that number should be that number, so it all works out. All right, number 17. H of P represents the cost of a company to manufacture P posters. What's the domain of the function? So what's the domain of the function? So it's you're producing posters, so you only have to produce posters in whole numbers, right? So you're going to do like 0 posters or 1 poster or 2 posters or 3 posters or whatever. So integers or negative numbers, all real numbers are decimals. You're not going to make a decimals and fractions and all the other numbers. So you're not going to make a half a poster. So it's either all positive rational numbers. No, that's fractions too. So the answer is C, non-negative integers, like starting with 0, 1, 2, or whole numbers. See, I call that a whole number. Okay, number 18, solve the quadratic. Okay, finally, an easy one. X squared minus 3x minus 4 is equal to 0. And this factors, which this is a solution to it. So we get negative 4 and positive 1. So you make your t, x minus 4 equals 0, x plus 1 is equal to 0. So x is 4, x is negative 1. So you could graph it and see where it crosses the x-axis, but 4 is definitely one of the solutions, so it's D. 19. All right, 19. Selective values. Okay, so a strong relationship means it could be a linear relationship. I think it says linear. So it's a linear relationship. So it could be a strong positive or strong negative. And the closer you are to positive or negative 1, that's going to be the strongest. So there are 2 answers for this, and it's those 2. So this would be a strong positive relationship because it's close to positive 1. This would be a strong negative relationship because it is close to negative 1. Okay, number 20. Okay, so this one here is talking about, hopefully you've read through this, it's talking about number of cars and number of hot dogs being sold. Yeah, if more cars go by, you're going to sell more hot dogs, but that's not necessarily a cause, it's more of a association. So the better answer is B. An increase in the cars is associated with the increase in the number of hot dog sales. So yeah, I mean, if you're a business owner and you're on a busy street, you have lots of traffic and people are going to more likely stop by your store versus some side street or whatever. But also if you have really amazing hot dogs, people will seek you out too. So it's more of an association than an actual cause. Okay, 21 is next. I'm going to draw myself a little rectangle here. A rectangle park has an area of 250 feet. What's the length of the park is 7 more than twice the width. Create an equation in terms of W to model the situation. So here's width, okay, and the length is 7 more than twice the width. So 7 more means plus 7 more and then twice the width. Okay, so the area would be multiplying these two together. So you have to type this in the box here. So 2W plus 7, and that's going to be multiplied by W, is equal to the area of 250. All right, number 22 is another exponential equation. And it says that we have this exponential equation here, f of x is equal to 2 to the x power plus 5. And it says we want to move this down. So this is actually the shift up and down with this plus 5 here. We're going to move it down 8 spaces. So if we go down 8 spaces from 5, that's going to take us to the negatives. So it's going to be 2 to the x minus 3. Because we're going to go down 5 all the way down 8 spaces to negative 3. All right, the next one here I believe can have multiple answers to it. You just have to make it work out so that the 25% of the data fits in the different places, and that's the first quartile and the median and then the third quartile. Just split the data up into 3. So this is what I did. I said 7 could be a number because that's the low, and then 17 would be the high. And then I need the I made 2 points at 9. Okay, and I did one at 11, and then I did one at 13, and then 2 at 14, and then 1 at 16. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's happening here is here's the numbers: 7, 9, 9, 11, 13, 14, 14, 16, 17. So there's the low and the high for your box and whiskers. The middle number, 1, 2, 3, 4, and then you've got this middle number, 1, 2, 3, 4. So there's the middle, so there's the 13 right there. And then the middle of the bottom would be 9, so there's that, and the middle of the top would be 14, so there's that. So that should work out for the dots. Okay, the last question is we're supposed to factor this. This is the difference of two perfect squares, because 13 times 13 makes, not 13 times 13, how about 14 times 14? So 14 times 14 is 196, not 13 times 13. Now remember, this is after school. Mr. Jackie is tired. So this is a difference of two perfect squares. It'd be 8x minus 13 and 8x plus 13. So the factoring pattern is the difference of two perfect squares, which is answer C. Hopefully this has been helpful. If you're a student here at the school, you can come ask me questions. If you're not here at the school, then this will be hard to come ask me questions, but I guess you could type a question at me.